we can also show the ionization of the acid in general, right? So maybe we have some kind of like carboxylic acid. Let's imagine it is like functional group, right? Some kind of like alkyl chain, alkyl group, right? Attached to the functional group of the carboxylic acid. And it can ionize, right? It's a weak acid, as we know from Gen Chem explorations, and it ionizes kind of like reversibly, right? So, and upon ionization, it has to make the ions, right? Such as kind of this part will be redrawn, except we're going to have O with a negative charge, right? And then acids need to need to donate the proton, right? So we're going to say plus, that's another product that will be formed. Technically speaking, the H plus, right? So that's it. That's going to be your anion and other like proton, right? So two ions, two counter ions are formed. So the total charge here will be 0 on the acid. It's a neutral compound. And it's going to be a total charge of 0 on the right side because you have -1 and +1 becomes 0, right? Total charge of 0 will be formed. So now, let's take a look at the further reactions. So here we are going to look at the merging between the carboxylic acids and the esters. So basically here what I want to say by that is that we are going to use carboxylic acids to synthesize esters, right? So that's what is going to happen. So what's going to happen? So let's take a look at the example, right? So maybe we have some sort of like acid, such as the let's do pentanoic acid, right? So that's our pentanoic acid. So that's what it looks like. So this is pentanoic acid. To make an ester, apparently you need to react your carboxylic acid with an alcohol, right, of some sort. So here we have, let's do maybe isopropyl, for example, right? So like this one. So CH, CH3, CH3 again, right? So they're going to make an ester, I can tell you what. So what's going to happen is that we are going to, due to the kind of like specifics or the mechanism, as they call it, of the chemical reaction, it was established that during this reaction of esterification specifically, right, this specific reaction results in the kind of like removal of the OH group and the H group from the acid and the what's it called, alcohol respectively, right? So this bond is still covalent, right? So it turns out that you can like show that for our like bond breaking and bond forming purposes, we're going to show the electron here, right? We're going to show the electron here as well on the oxygen, right? So, and then guess what? So you have liberated electron here once the OH departs. You have the liberated electron here once the H departs. So H and OH will make, guess what? H2O. They will make water, right? So this reaction is reversible. It's called esterification. It's called Fischer esterification, which is carried out in the presence of H2SO4 that serves as a catalyst to make the reaction go faster, right? So, and then, yeah, we're going to show here our H2O, okay, like, or HOH if you want. HOH, H2O, same things. So, and then finally, drum roll, please. The ester shows up, right? So we're going to redraw lots of things. So like CH3, CH2, CH2, CH2. Okay, and I have redrawn them. Carbon with the carbonyl. So this is our free electron, right? So now we have the oxygen with this free electron, right? So free electron, oxygen, and draw the rest, which kind of like stays intact, right? So now they are going to be connected like so. So now you have what? You have an ester, right? So you made an ester. So you see, you basically now have your like all the like significant parts of the ester, right? You have this part, right, which came from the acid kind of. So if you just look at the ester in isolation and this stuff, the alkyl substituent, which kind of like switch the H on the hypothetical acid, right, from which this was synthesized, this guy, by the way, right? So yeah, that's kind of like what you have here. You do get the ester upon this reaction. So essentially, generally speaking, right, so we need to use the carboxylic acid and an alcohol in the presence of H2SO4 to have on our hand the Fischer esterification reaction that results in the formation of the ester, right? from the respective carboxylic acid and alcohol and the water molecule. So yeah, that's it. So that's what we are going to have as a result of this esterification.